If you're building AI agents, but they keep forgetting what just happened, this is your fix. Today, we're gonna set up a full stack memory system with both relational and vector databases using nothing but free tools. Let's get into the build without further ado. So to start off, we are just gonna put in these very bare bones pieces, which is our trigger. When the chat message is received, we're gonna trigger this workflow. And so to do that, you just wanna go here and you wanna click add another trigger, and you want to click on chat message. That's how you get this one. And then there's also the AI agent step. You're gonna click here in order to get this AI agent setup. So that is the bare bones setup. And with that, let's go ahead and build on top of it to get the full setup that I just showed you. We need first a large language model. So our AI agent is going to be using OpenAI, and we're gonna pass in ChatGPT 4o. You're gonna wanna connect this to your OpenAI account and then hit save. And so we are going to give it memory like we just talked about. We're gonna give it Postgres chat memory. And so I'm gonna walk through the setup with you of how to connect your Postgres and your Supabase credentials to N8N in order to get this set up. And so we're just gonna go ahead and click create new credentials, and then we're going to need to put in all of this information. So to do this is all gonna be set up in Supabase. So if you go to supabase.com, you'll see something that looks like this, and we can just go ahead and click start your project. And then it will require you to sign up with a new account. You can create a username and password. It will allow you to confirm your login, and then you can create a new organization. Once you create a new organization and you label a new project, in this case, I just created a new project for demo RAG agent, then you're gonna get to this page. Once you're at this page, you're going to wanna click connect. Once you click connect, you're gonna go to PSQL, PostgreSQL as the type, and we're going to want to look for the data that is within transaction pooler. We can actually view the specific parameters here. And so now we look at what N8N wants from us to connect our Postgres account. It wants a host, database, a user, a password, and our port number. And so for our transaction pooler, we can get all of this information. And so we're just gonna pass all these things in. We're gonna pass in our host. We're gonna pass in our database, which is just gonna be Postgres. It shouldn't be any different for you either. Our user, our password is going to be the password that we've set up for our database. And so when you create a new Supabase account, you have a database password. You can just go ahead and paste that password in here. If you just paste that here, that is perfect. And then you want a port number. So the port number is gonna be the last thing that it asks from you in this transaction pooler information. So that is all we need. We're just gonna hit save, and then it has given us a green connection tested successfully. And that is our Postgres account. So now our Postgres is connected. And so what this does is it stores our chat histories in a new table called N8N chat histories. And it stores the most recent 5 chats. And so I'm gonna demo this real quick to show you what this looks like. If we hit save and we just hit open chat and we type a message, we just say hi, then we can see that 2 calls were made to our Postgres chat memory. And so when we go to our Supabase account in our project that we just created, we can actually see this chat. So if we go to our N8N chat history, if we go to our table editor, you will see N8N chat histories, and you can actually go ahead and see what was passed in. And so we had a human who passed in the message content hi, and it had this particular session ID. And so you can see that session ID that ends with 2DE matches exactly what was passed in to here with this session ID as well. So you can see that this session ID matches exactly what was passed into our database. So we know that it's the exact same chat that it's referring to. And so if you want to go in here and look at the response, this AI responded with, hello, how can I assist you today? And so we see the same thing coming up in row 10 here. In this case, it's row 10. For you, it'll be row 2 because you'll have a new account. This will say, hello, how can I assist you today? And it'll be the AI talking, and it'll be the same session ID that we just referred to. And so all of your chat histories are going to get stored in this table that was just created for you called N8N chat histories. So hopefully that makes sense. And that confirms that our connection setup works properly, and we can move on to the next step, which is connecting our Supabase vector store. And so that is going to be as one of our tools. We're going to create a Supabase vector store. And I will walk through how to connect the credentials for your Supabase. And so if you click create new credentials, Supabase is going to need a host and a service role secret. And so the way that we do that is we go back to our Supabase project. We go over to project settings, right? In project settings, you want to go to data API, and you have the project URL, the service role secret. These 2 things refer to your host URL and your service role secret. So I'm going to copy this project URL, paste it here, and then I'm also going to reveal and copy this service role secret and paste it here. And I'm going to do that right now. And then we click save. Connection has been tested successfully. Green is good, so we are good to go on that. Supabase is connected, and we can leave these things for now until we add data to our vector store, which I will show you how to do next. So let's leave this out for now, and let's go ahead and pass in documents to our vector store. So we're going to create another trigger and another setup to pass in documents to our vector store. So when we click test workflow, we are going to pass in a new document. And so we're not going to pass in a document, we're going to download the document and then pass that into our Supabase vector store. And so the action here is to download a file. So I already have a file to use for this demo. It is this file right here, which is LA Commercial Real Estate Absorption Trends and Projections as of March 2025. And so I'm going to pass this in to the AI agent to give it information for its knowledge base. And so I'm just going to find it from my search. And this is the exact document that it's going to go ahead and download. And I'm just going to hit test step. There we go. And so what this does is it outputs the file in binary. So it takes the file contents and converts it to binary. And that is great for us because then what we're going to want to do is add that to our Supabase vector store. And so Supabase vector store is the next step. We're going to add documents to our vector store. Which documents are we going to add? Which table are we going to add our documents into? We're going to add them to this table called documents. And so as long as you followed the previous step, where you connected your Supabase account, when you go back to your Supabase project, you will see in documents a brand new table called documents. So what you should see right now in your Supabase project is a brand new table called documents, and it will be empty for you because you have just set up a connection to your Supabase vector store. So as soon as you did that, it created a blank new table called documents. So we are going to refer to that table when we say which table do we want to add documents to. It's going to be that documents table. And we're going to say our embedding batch size is 200. We're going to leave that as is. And then before we test, we're going to have to actually add in a few other things, which is to add in an embeddings model, which we're just going to use OpenAI's text embedding 3 small. That's totally fine to use. This is essentially the way that we convert our data from binary, which is given here, into a vector embedding, right? So an embedding is essentially converting that data into vectors. And so we have our embedding model to do that. And then we also have a data loader, which takes in binary and passes in the output of our embedding model into our vector store. We have our default data loader that takes in binary data. So by default, it will go to JSON. We want to select binary specifically, and then we're going to say load all input data. So whatever's passed into the vector store, we're going to use this default data loader and pass in binary data. And then that default data loader is going to need a text splitter in order to split the binary data into chunks. And so before vectorizing the data, it needs to create chunks of size 1000 with a chunk overlap of 0. So you can modify this. There's a lot of science and research that goes into how big to make your chunks, depending on the data that you have, for the most accurate knowledge retrieval and how much overlap to use in order to get the best output from these AI models. That is a whole nother leg of research. But for this demo, for what you want to use for your business, these default settings do work really, really well. And so you can just leave the chunk size to be 1000 and the chunk overlap to be 0, and that is perfect. And so we're gonna leave that there, click save. And now we are good to go, where this entire setup is taking files from our Google Drive, whichever file we wanted or whichever folder we wanted, passing all of that into our vector store. It is loading the data, it is creating embeddings from the data, it is splitting the data, etc., putting that all into our vector store. So we're gonna hit test workflow and we're gonna see how this works. We're seeing it run right now. Everything looks green and it gave us 10 items as an output. So you might wonder what these 10 items are because we just uploaded one file. Well, it took that one file and it split it up into 10 separate chunks that were all passed in as individual embeddings. You can see these embeddings here. That's essentially what matters here, is these embeddings and the values of these embeddings. And so all of that is passed into our vector store, and now our vector store is full, which is great. Just a quick note on this. When you're using this vector store, what this AI agent is doing is it's taking your question that you ask it, it's converting that into a vector, and then it's looking for which vectors here is most similar in value to the value of your query vector, your question vector. And it is pulling the most relevant numbers, taking those chunks, and then using that in its answer. That's essentially how it does vector search. That's how vector search works. And so we're gonna do that. We're gonna use that here. And so now that we've set that up, we have documents in our vector store, we are just gonna finish out this configuration over here in this AI agent. And so I'm just gonna name this to be LA broker, commercial real estate broker. Use this information to answer accurately. You can put any prompt there. You could add more detail to outline what this vector store is really gonna do. Which table are we gonna use? We're gonna use our documents table, and we're gonna grab the 4 most relevant chunks. We can change this, but you don't need to. This will work perfect. And then you can just add an embedding model, which again, use the same embedding model that we used earlier, which is the text embedding 3 small. That works perfect. We can just hit save, confirm that this is set up properly. It seems that we need an alphanumeric string, and so we cannot have spaces, which is totally fine. LA broker there works. We can hit save. And now we are good to go. So we've added documents to our vector database. And now we can go ahead and open chat and test it out. And we can say, what are absorption rates in LA? And so we know we passed in knowledge around absorption rates in LA. And we can see how this AI agent is working. It's using the memory, it's using the vector store, it's grabbing the most recent or relevant vectors and then responding. And so it gave us a lot of information about the office sector, retail sector, multifamily sector. And we can see the office sector present absorption is around negative 64,303 square feet in downtown LA. And we can see that that is accurate right now as of March 2025. And so you can see all of this stuff is pulling directly from the document. So that looks good. And you can play around with this, ask it more questions if you like, get into more detail with that chat. But that's essentially how this works. And that is the most basic setup for how you can add documents to your vector store, use Postgres memory, use Supabase for vector search, for accurate retrieval augmented generation. And then now you have an AI agent that is responding precisely, accurately with memory. And then you can do a lot more with this. You can create more complex setups. You can have it re-upload documents as you update them. So let's say I come into this document and I change it, or I add new documents to a specific folder. You can have a workflow that adds new information into your vector store as you update the documents or upload new documents. And so that is also another workflow that I'll cover in another future video for the most accurate AI agent. While you're talking to it, it has the most accurate information. Hopefully that all makes sense. Hopefully you were able to follow along with me. And again, this workflow, this setup is available in my resource hub. So if you want to go ahead and access this, you can click the link below this video to access the resource hub. It is completely for free, and you can download and upload this particular workflow to your N8N environment, and you can get going and run this for your data, for your business. So hopefully that was helpful, guys. Let me know if you have any questions in the comments, and I will see you all in the next video.